This week we're starting a 2-week series where we start talking about objects and classes, which is really the heart of any object-oriented programming language. The first thing that we have to do is define the difference between what an object is and what a class is. A class is the design methodology used to create an object. You can think of it like the blueprints for a building. It is the design, it specifies where things go, but it's not the actual object itself. If we were talking about a building example, the blueprints would be the class, and the building, what actually is constructed, is the object. So the textbook definition is a class defines the object, such as what methods and attributes that object is going to have, and an object is an instance of a class. So let's go ahead and jump into some code so that we can see the difference between what a class is and what an object is. As you can see, whenever you start a console application in Visual Studio, you'll see that it automatically creates a class for you. This class program is the base class of the console application. It contains the main method, which is, as we know, the method that's first executed when we start the program. To define our own class, we can just simply come down here and use the keyword class to create a new class. Just as up above, you can see a class is immediately followed by an opening curly bracket, and then there's a closing curly bracket down there. So we need to do the same thing in our class. We open the braces right after we define the name of the class. So we use the keyword class, and then we created a class called myClass. Inside myClass, we can define different attributes, different methods, and other things that we'll get into in just a few minutes. For now, let's just create a couple of attributes. Let's do a string name, and we'll do an int, and we'll just call it value. So this is an extremely basic class. The class holds two different items. It holds a string and it holds a value. Now, if we want to create an object based on that class in our main method, we have to declare it like we would a variable. So we use the keyword myClass, and then we give it a name, and we're just going to call this my object. And that's how we create an instance of the myClass. Now, there are a few other things that we have to do to get it to work. We'll go over into that in just a few minutes. So this is a really good time to start talking about the differences between public and private. I believe earlier in the class I touched on the fact that you can create public variables and you can create private variables, where public variables are accessible by any class within the program. Private variables are only accessible within that class. You can't access them outside of the class. To declare a variable as either public or private, you just use the keyword either public or private in front of the variable. As you can see, I've made the string name a public variable, and I've created the value as a private variable. This means that outside of my class, anything, so I could access that value up here in the main method, but I could access name up here in the main method, but I could not access value up here in the main method. You can also define classes themselves as either public or private. So most of the you're going to see that classes are going to be defined as public. Private classes can only be accessed within a very specific set of circumstances. So they don't get used very often. So you normally are going to use public classes when you are creating new classes. It's also a good idea to get into the practice of going ahead and declaring your class as public instead of just leaving it blank. We'll get into why later on down the road in the class. So now we've defined a class. We've actually defined a public class. We've given it a couple variables. I'm going to go ahead and switch this back to a public. We can also create methods within my class. Declaring a method within the class is the exact same as declaring a method within the main. You do you tell it what type it is you're going to do, and then you have to give it a name. So we'll just call this my method, and then you have to say whatever variables you are going to be putting into that method. So if I wanted to read in a string, and we'll just call this my string. Whenever you access this method, it's going to force you to put in a string variable in there so it can do something with it. So again, just like with variables within a class, a method needs to be defined as either public or private as well. Public methods can be accessed outside of the class, where private methods can only be accessed within the class. So if I were to create a private method down here, that can only be accessed from within this class. So I could access my private method right here if I wanted to, and that's valid code. You can see I don't get any errors doing that. Okay, I paused the video for just a minute so that I could go ahead and create a more robust class to demonstrate with. So you can see I've created public class car. I've given it several attributes. Most of them public, a couple of them private, and I also created a couple of methods where I am setting the car information and a private method where I'm setting the horsepower information for this class of car. Now remember I said earlier that the class is the definition of an object. So this isn't an object yet. We actually have to create the object. To create the object, I'm just going to come up here in my main method. I'm going to create a car and then call it my new car. And by doing so, I have just declared the object, just like I've declared a variable, but I have not yet initialized the object. For me to actually fully create an object, I need to set my new car equal to something, and I can just go new car, boom. And what I'm doing is I'm saying, okay, I've declared that I'm going to create a car and call it my new car, and then I'm going to create the instance of the car and set it to equal to a new car. So with objects, you have to declare the object, and then you have to do what's called instantiating an instance of that object. You have to create the object. One of the most common errors that beginner programmers will have, and I promise you sometime in your career you will see the error come up in Visual Studio that says object not set to an instance of the object. If I were not to do this, and I tried to access something on my new car, so let's say I tried to set brand equal to something, I can't do that because there's no instance of the object created yet. So I need to do my new car equals and then create a new car. So what I'm doing when I use this keyword new and say car with those open parentheses is I'm actually accessing a special method within the class, and that special method is called a constructor. In C#, if you do not define a constructor on your class, the Visual Studio automatically will create, or actually the C# language automatically assumes there is something called a default constructor in your class. When creating a constructor, it's very similar to creating a method, with the exception that you cannot say a return type. So in a method where I say public void, here is my return type, for a constructor, all I do is say what the name of the class is. Okay, so to declare a constructor, all constructors have to be public. There are some instances where you can use a protected constructor, but that's further on down the road. So for now, just assume that all constructors are going to be public, and they're also going to be the exact same name as the class itself. So you cannot declare a constructor with a different name. If you can see, if we try to do that, we're going to get an error, and it's going to say, it's assuming that you're trying to create a method, and it's going to say the method has to have a return type. So again, creating a constructor is a method, so you are just going to set parentheses. You can actually ask for people to put values in here. I could do string, my string, and that is a valid constructor. It will force, whenever you create an instance of the car class as a new object, you have to put something in there. You can see that I'm getting an error up here now because of that. If I don't put anything in there, I have what's called a default constructor. Now, when you just allow Visual Studio in C# to create your default constructor for you, it doesn't do anything. It just does the bare minimum to make the object. There are a lot of times that you'll want to have your default constructor doing something else. When we start talking about different types of collections that we might create on a class in, I think it's 2 or 3 weeks, you'll see where that default constructor having something in it is going to be valuable. So for now, you can either create a default constructor yourself, or you can allow C# to create an automatic default constructor. That's okay. But just know that even if you don't type it in, all classes actually do have a constructor method. We'll go into next week a little bit more detail about what you can do inside constructors, how you can actually use constructors to set different variables within the class, and do a little bit more complex work with constructors. But for now, we're just going to concentrate on classes and objects. So another thing that I want to point out is the naming conventions that I used when I created my class. You'll notice for my public variables, all of my public variables are using Pascal case. So they start with a capital letter, and if there are more than one word in the name of the variable, like as an example, top speed, the second word starts with a capital letter. My private variables I set a little bit differently. You'll notice that I'm starting with an underscore, and I'm using a lowercase to start with and only doing an uppercase when I start a new word. This is a camel case with an underscore in front of it. So camel case, you start with a lowercase letter, and then every word after that has a capital letter. This is typical naming convention for most programs where you'll have your public variables inside a class having the Pascal case, and your private variables, either they'll be camel case most of the time, for just because we're defining them as a private and you never see them anyplace else, they use this underscore in there. You'll also notice that when I created my method here, that I used all lowercase on these, and the only reason I'm using all lowercase is because I'm actually using camel case here. So if I were to make this car brand and car model, you'll see that I'm actually using camel case there. That's a little bit better example of it. Let me just fix my class here. Okay. And then for the methods, I'm always using Pascal case, whether or not it's public or private. So C# will work if you, I mean, you could just put in all lowercase letters here, or you could put in all uppercase letters here. The only reason why I bring up the naming convention that I use is that it's just the typical naming convention that you see outside in the real world. Most programming jobs that you have will define that they want you to use standard methodology when naming variables, methods, classes, and the like. So now that we've created the public class car here, and we've started to instantiate the object up here, let's actually do something with it in code. So now that I've created the object my car, I can actually access all of the public variables and public methods on that. So I could say my new car dot set car information, and I can actually enter in the information that I want. So let's do Ford Mustang and we'll call this a GT. So this is valid code. I'm accessing the method that is on the object that was defined in public class car right here. So when I run this method, it's going to execute the code that's in between those two curly brackets there. Now, I can access my public variables directly as well. If I go mycar.brand, I can set that equal to a value directly as well. I do not have to use a method to set my public variables. Not only can I set it, but I can read it as well. So you can see we didn't get any error messages from Visual Studio there, because it is just going to take the variable brand, which is a string that currently is holding the string Ford in it, and it's going to write that to the screen. If I just do a console.read here, debug the program, you can see, boom, that's what it output to me. So anything that's public, you can access it directly. Anything private, you can't access. If I were to come down here and try to access the set horsepower, you can see we are going to get an error, and it's going to say that it is inaccessible due to protection level. That means that it's a private method. So you can't access the private method outside of the actual class itself. Notice I can access it here. So inside the class, I can still use that, but I have to have a public method to actually get to this private method. I also cannot access these private variables that I put in there. So if I were to come down here and try to access, you can see when I do the underline, oops, you can see it doesn't come up with anything, and it's going to give me an error saying that, hey, you really can't do that. So we'll delete that out. The last thing that we're going to talk about, and really the only reason that we're talking about it is because you do need it for your assignment this week, is doing an override. There are certain methods, just like Visual Studio will automatically put in a default constructor for us if we don't put it there. Visual Studio will also create certain methods for us as well. So one of those methods that you'll always see on every single object that's created is the toString method. if I run toString, what this is going to do is it's going to take this object or some attribute of this object and convert it to a string. You can see if I run this, it's going to give us some not very useful information. It's basically just returning, what namespace we're in and what class we're using. So the namespace, I happen to use week4 as my namespace .car. Not very useful information. If we wanted to say change that so that instead of just writing the name of the class, we wrote the brand, model, and type of car, we could do that with something called an override. To declare an override, you just do, we're going to make this public, and you just use the keyword override, and then we're just going to override toString. So actually there was something I should have typed in there that I let Visual Studio do for me. We need to also set the type that we're returning, so the return type. So keyword public to say that anything can access it, override to let it know that we want to take the default toString method and we want to use our own, and then the return type, which is going to be a string. Now, my version of Visual Studio automatically put this line of code in there, and all that's doing is saying that for this method, we're going to return the base class's toString method, which is not what we want to do. We want to override that with something else, with our own stuff. So we're going to delete that out, and we're going to put, let's just do return, and then we're going to return the brand, and then we're going to put some formatting in here, the model, and the type. So what that will do is it'll take these three strings up here, it's going to put a colon in between them, and then it's just going to return that string. So now when I debug the application, you can see we come up with Ford Mustang GT. Probably the most common method that you're going to be overriding in your beginning programming is this toString method, so that you can actually make toString useful. Once we get into more complex class diagrams and where we're using something called inheritance and polymorphism, there's going to be other ways that we're going to be using that override keyword to make our class do cool things. Okay, so finally let's take a quick look at assignment 4. This is what you'll be doing this week for your assignment. You can see we're using basically what I went over tonight. I don't think there's anything else that you're going to see that you're going to need to know how to do. Really, all I want you to do is to create a console application and create two classes within that program. So we're going to create a class called student, and we're going to create a class called class. These are the attributes that I want you to use. The little plus sign here means that I want those to be public variables. If I put a minus sign in there, that's private. That's just typical class diagram methodology. So you may remember that from CINS 113, where the plus means it's public, the minus means it's private. So what I want you to do is I want you to create those two classes. I want you to create a method on those for getting information and storing it in those. Probably should have used the keyword set instead of get. I apologize for that. So this should be a set student information, because you are setting all of those variables up there, and then set class information because you're setting those. I will change that and upload the file again. And then I want you to override the toString method. So I want you to use that override right there, and I want you to do something a little bit different for it. I want you to write the all the string information up here in a readable formatted method. I'll let you decide what you consider readable and formatted, what exactly you want it to look like, as long as there's some string and some formatting in there. So then you'll just zip that entire file and upload it to Blackboard. Again, if you have any questions, feel free to email me throughout the week or use the I Need Help forum. Other than that, have a good week, class, and we'll be talking next week.